Coroutines are a very special type of method. In order to use them, we have to have the using system.collections line at the top of our script. By default that's there, and we can see it in this script on line 2. The special thing about coroutines is that while normal methods can return a value or return out of the method early, coroutines have the ability to return out of a method and then return back to that method at the exact point in which it left previously. This allows us to break up long operations across multiple frames or even long delays of time, instead of doing all of the lines of code at once. Using coroutines might seem a little confusing, but in reality, it's very simple once you understand the syntax. Let's go ahead and set up a system so we can see exactly what's happening within a coroutine. To do this, we're going to use the update method. And inside the update method, we're simply going to output to the console. This is going to output the word tick to the console every single update frame. This will allow us to get some sense of timing as we're running our coroutine. Now let's actually write our coroutine. All coroutines have a special return type which is called IEnumerator. The IEnumerator data type is found inside system.collections, which is why we need the using system.collections line on line 2. Let's name our coroutine something like sample routine. Coroutines can take parameters, but in this example we're not going to. Now we're going to write to the console to see in the console exactly what's happening inside our coroutine. First, we're going to write routine started to the console. Then, we're going to skip a frame. What this effectively means is that we're going to leave the coroutine right after writing routine started, and then we're going to come back to the coroutine in the next update frame. Since we'll be coming back into the coroutine exactly where we left, we won't see the text routine started again in the log. Instead, it'll pick up right where it left off. In order to skip a frame, we're going to use the return keyword like we've seen with other methods, and another special keyword called yield. Yield is used with coroutines, and it basically says yield execution of this method or coroutine, and then come back later. So the line of code I'm going to write is yield return null. Null basically means nothing, and in this case means leave right now and come back immediately in the next update. Now let's see how we can use coroutines to skip an amount of time. Again, I'm going to write out to the console. And we're going to say that we've skipped a single frame, and now we're going to skip 0.1 seconds. To leave this coroutine, again we're going to use the yield, return keywords, but now we don't want to come back in the very next frame, we want to come back after 1/10 of a second, or 0.1 seconds. To do that, we're going to use a data type we haven't seen yet. The line of code is going to look like this. Yield, return, and then we're going to return a new wait 4 seconds variable. And we're going to pass into the constructor of that variable 0.1f, meaning 0.1 seconds. This whole line basically says, leave this coroutine, and after 0.1 seconds, come back at this point. Finally, I'm going to write out to the log and say that we've reached the end of our coroutine. Now before we head back to Unity, even though we've created this coroutine, we still need to actually start it. So let's go ahead and add a start method. In order to start a coroutine, we can't just call it like we would a normal method. Instead, we need to use another method, a special method, to start it, called start coroutine. Inside start coroutine, we're simply going to type the name of our coroutine. Inside start coroutine, we can type in the name of our coroutine. We can type it as its actual invocation name, like this, which will cause it to invoke that method as a coroutine. Another way we could write this is as a string. The benefit of starting a coroutine as a string means we can stop the coroutine using the method stopCoroutine and also passing in its string name. The trade-off is that using strings, as opposed to simply invoking the method, is a little less efficient. We don't really need to stop the coroutine in this example, but we do often inside the Zombie Toys project, and so I'm going to leave it like this so it's more familiar when you see it later. Now that we've written the coroutine and started it in our start method, let's hop back over to Unity and see how it works. Let's go ahead and hit play. And we'll notice real quick that update is writing tick continuously, which makes it very hard to find the messages we want in the log. One thing I forgot to do, let's go back over to our script, and at the end of our coroutine, right after we say reach the end of routine, let's go ahead and disable this game object, which will make update stop running, which means it'll be easier to see our messages in the log. I'm just going to write gameObject.setActive and pass in false. Now in Unity, let's try that again. There we go. Now if we look at our messages, we can see that our routine started, and then update ticked. It ticked again, which is an important concept. I'll talk about that in a second. And then we see 1 frame skipped, and then we see 2 more ticks, and then we reach the end of the routine. What this effectively demonstrates is that our timing does in fact work. If you're wondering why we see 2 ticks between routine started and 1 frame skipped, the answer is quite simple. It's just a matter of understanding how the timing works. Our coroutine was started by the start method in the same frame as the first time the update method runs, so we see 1 tick. From then on out, all coroutines are run after update has finished. So the next frame, update runs, and then our coroutine runs. Therefore we see 2 ticks. If we really want to stretch out the time between our 1 frame skipped and the end of our coroutine, we can certainly do that to see a more exaggerated example. Let's say, instead of skipping 0.1 seconds, we'll skip 1 full second. Now, let's run it again. We'll press play, and there we go. We now see 62 messages. We can see routine started, our 1 frame skipped, followed by a series of ticks from our update method. And then finally, we reached the end of the routine. Another thing coroutines are really useful for is spreading the iteration of a loop out over several frames. Let's say we have an array of strings, like we've seen in a previous example, and what we'd like to do is output one of those strings every second. We could build some form of timing protocol inside update, or we could use a coroutine to handle this. For this example, we won't need the update method, or any of the code inside our current sample routine, so let's get rid of that. First, I'm going to go ahead and declare a public array of strings. That way we can access it and fill it up inside the inspector. Now, inside sample routine, let's go ahead and create a for loop. We should be familiar with for loops from a previous section. The for loop will be for int I equals 0, I is less than mystring.length, and I++. Inside the for loop, we're simply going to output one of the values of the mystring array, and then we're going to wait and then loop again. This is a very common way of spreading the iteration of a loop out over many frames. Finally, we're going to write out to the log that we have finished our routine so we know that it's done. Let's hop back over to Unity now and see it work. We now see the mystring array that's part of our coroutine script. And let's go ahead and put some values in there. Let's fill it with the days of the week. Now, when we run this, we should see 1 day per second written to the console log. And there we go. You can see the iteration of that loop was spread out over 7 seconds.